I told you that I wanted to show you what this graph looked like. We predicted that this graph in example 2 was going, not this, I'm sorry, this graph, the graph in example 2 was going to limit itself out on the right side, approaching 3/2. And so I just wanted to show you, this is what the graph looks like. I'm going to come over here, and in Y2, I'm going to put 3/2. And you're going to see that it does level off as x approaches positive infinity. As x approaches positive infinity, that means it's moving to the right, moving to the right. The function is getting closer and closer and closer to this red line. It's flattening out, it's plateauing, it's leveling off to this limit in red, which is what we had predicted it was going to do. So just remember, limits at infinity, and by limits at infinity, I mean limits at infinity, means we're looking at end behavior. And if there is a number that we get out of it, that means it's flattening out, it's leveling off. If we don't get a number, that means the end behavior is either going up to positive infinity or down to down to negative infinity, but it's not going to approach any value. So we're going to do these three here in video 2 to kind of get the feel for how do we tackle these. Remember, we said whenever you're dealing with a limit at infinity, we're dealing with end behavior. You don't need to worry about everything. Worry about the biggest term on top and the biggest term on the bottom. So I'm going to say that the limit we're given in part A can also have the same outcome as the limit just looking at the leading term on top divided by the leading term on the bottom. Let's use this green. Not because these are the first terms, but because these are the terms that have the biggest power of x, right? They're the ones that produce the biggest magnitude. And now we simplify. Be careful. I know, and you know, because we're multiplying 5 times x squared, that this and this are going to reduce. But it's very common for students to say, oh, my answer is 5. Well, no. Where was the 5 to begin with? It was in the denominator, so therefore my limit is 1/5. So I'm claiming that if you graph this function x squared plus 4x minus 6 all over 5x squared plus 9, and you look at the end behavior on the right side as x gets closer to infinity, positive infinity, it's going to level off to 1/5. How do we do that? By focusing on the largest terms, the terms that have the biggest magnitude, and comparing them. Because limits at infinity are all about comparing magnitudes of growth as x gets bigger and bigger and bigger. What's the top part doing? What's the bottom part doing? And is there any relation there? Um, I look at part B and I say, okay, well, there's a limit at infinity again. So I can focus on the biggest term only. So the biggest term in the denominator, that would be this guy. But what's the biggest term in the numerator? Well, we haven't multiplied everything out, right? And so we say, well, what would be the biggest term here? Well, this would be the biggest term here. Be careful. Take the sign with you. Well, what would be the biggest term here? Well, this is the biggest term here. And since we're going to multiply it anyway, the biggest term you would get when you do all that distribution would be the one that we get with these red terms when we multiply these two. And so that's going to be negative 6x squared. Can we reduce anything? Heck yeah, we can reduce the x squares. And so what am I left with is negative 6 divided by 3, which is just negative 2. That's the limit of this function as x approaches infinity. As x gets bigger, my graph is going to level off and approach negative 2. What about letter C? Is it a limit at infinity? Yes. Okay, that means I can focus on the biggest term in the numerator and the biggest term in the denominator. So in the numerator, that would be this guy, not because he's first, but because he has the biggest power of x. And then this one. What happens in this example? Do all of the x's reduce out? Well, no. Only 2 from the numerator and 2 from the denominator are going to cancel out. And what you're going to be left with is 4 over x. And we said whenever we have a number, and if you keep plugging bigger numbers in the numerator, in the denominator, I'm sorry, you're going to get 4 over infinity. And that's just going to make that fraction go smaller and smaller and smaller and smaller and smaller, which means this is approaching 0. Whenever a situation is bottom heavy, then the limit as x approaches infinity is just going to be 0. It's going to level off, but it's going to level off towards the x-axis. And those are 3 examples of limits at infinity. Again, an example where we have a balanced situation, and then an example where we have a bottom heavy situation. When we come back, we'll do example 4, and then we'll wrap this up.